NPTEL course on urban utilities planning, water supply, sanitation, and drainage. The course instructor is Dr. Devapratham Pandit, Associate Professor, Department of Architecture and Regional Planning, IIT Kharagpur. I'm Monica S. I am a research scholar at the same department. Uh, yeah, these interactions are part of the weekly interaction session that has been handled by PMRF scholars across the country. So for each of the NPTEL courses, we've been assigned one or two scholars depending on the course load. I'm one of them. The other scholar for this current course is Jeslu Celine Jacob. Her sessions are usually on Tuesday evenings. Right? So we have two major uh, platforms for interactions and clearing doubts for the course. One is this session, which is conducted every Monday, 7 p.m. to 8 p.m. You can raise your hand, unmute, and raise a query after every question or so. Or questions can also be posted in the chat box. We also have a discussion forum for the course where any questions related to the live sessions can be raised. They'll be addressed either in the forum or in the next week's live session. Right? So week 10 was all about sewer appurtenances. Appurtenances are essentially accessories. So it's not just enough that we have pipelines laid to handle water supply, sanitation, and sewage. We need certain accessories in the entire system that can sort of enable us in the provision of services, whether it's water supply or uh, sewage collection and treatment or drainage. In fact, in most other utilities also, we'll have some form of appurtenance that is in place, right? So the first two lectures were an introduction to the types of sewer appurtenances that are usually employed, including manholes, drop manhole, flushing manholes, sand silt and oil trap, gutter and inlets, culverts, inverted siphons, overflow systems, pumping stations, some of which we also saw in the previous lecture. So we saw a small clip on pumping stations last time as well. Then we saw outfall structures, backflow prevention devices, erosion control and drainage in heavy areas, temporary erosion and sedimentation control practices. Right. So these were covered in the first 2 weeks. Uh, Lecture 48 focused on stormwater drains, including the basics, some hydraulic routing of stormwater, open channel stormwater drain design, and modified natural channels. So, in hydraulic routing, we saw that we can employ multiple types of equations, accounting for the level of complication that we want to involve regarding flow of sewage, right? And then lecture 49 was on sewer maintenance and cleaning. Uh, we saw an introduction to sewer maintenance, inspection and examination of sewers, indirect inspection, sewer cleaning, inspection and maintenance of stormwater drains, desilting of stormwater drains. And lecture 50 was on laying of sewer and utility corridors. So sewer layout and installation, trenches and tunneling, laying of pipes and backfilling, testing of sewer lines, utility corridors and ducts, sewer layout and installation, as well as utility ducts, were the focus of this lecture as well. So, especially Ashwin, since you weren't present in the last session, if I remember right, we had some general relevant content on the calculation of, um, or rather, the design of sewage sewerage systems. There are a couple of interesting apps that were also introduced. So, I mean, I would recommend that you take a look at it as well. So, this live session will be quite short. We have most of the questions are actually overlapping with this year's assignment questions. So, we'll be looking at a few of the previous runs assignment questions for the corresponding week. but we'll be restricting ourselves to the few questions that were not overlapping, right? So, moving on to the lecture. Uh, the question 5 in the assignment was to match the following: manholes, dry pit systems, flap gates, and check dams. Uh, any answers as to what the correct answer is? Any responses? All right. Okay. So, yeah, I mean, you are right. The answer is A, Mr. Ashwin. So, essentially, manholes, looking into the content from the lectures, manholes are appurtenances that help connect ground level to opening in the sewer line for maintenance and any kind of checking. It generally consists of a working chamber, an access shaft, and a strong cover on top, which is usually flush with the road level. We've seen a number of social issues around the entire concept of manholes and workers accessing doing sewage maintenance and cleaning through manholes is very inhuman, and a few new technologies have come up replacing humans as the medium of contact with sewage. uh, they've been up and around. So with regarding to pumping stations, so I know the question was probably mildly ambiguous, because I mean dry pit, wet pit, they could also refer to the pits that we usually, the soak pits that we have. But however, if we look at the answers, we see that it's actually regarding dry pits, as in pumping station dry pits. So dry pit pumping stations, basically the pump doesn't come in direct contact with the it's not immersed in, it does of course come in contact, but it's not immersed into the sewage as such. So the entire setup, so this setup is sort of in a dry area, right? It's not immersed. And backflow prevention devices, one of the devices is a flap gate. A flap gate essentially allows for, it's like a valve that allows for unidirectional flow, right? So again, pardon my drawing. If this is the end of the pipe and there is water, this flap gate is sort of attached here, right? So if water is flowing in this direction, the gate is kept open. However, if it flows in the opposite direction, the gate sort of shuts down, and that's how the basic mechanism works, right? So that's a flap gate. And check dams are essentially small temporary dams constructed before a swale across a drainage ditch to reduce the runoff velocities and resulting erosion. So, usually, even when we have a swale, if the velocity of movement, especially because all of the water is sort of collecting in this area, we can expect the velocities to be quite high, right? But if we build a check dam, it will sort of retain the water. So, once this check dam is built, water will have to flow very slowly over this, right? It gets collected here, gets stopped, and then it sort of flows over the check dam once the volume is more than the check dam's capacity. Or even if it's not, even if there is a bit of bounce, it sort of reduces velocity. That's the entire idea, right? So yes, the answer is A. Any questions on this? So moving on to the next question. Stormwater facilities has to be inspected regularly for A. Scouring of bed and sites, B. Full or partial blockage of the drain, that is siltation or dumping of solid waste or debris, and C. Damage to drain structure. Any answers? Right, let's look at the slide, corresponding slide. So this is from the lecture talking about the inspection of and maintenance of stormwater drains. So we can see that all three aspects have to be checked for. So stormwater facilities has to be checked for, have to be checked for scouring of beds and sites, full or partial blockage of the drain, and damage to drain structure. There are multiple ways of doing this. There is indirect and direct inspection, if you remember from the lecture. So the answer is D. Moving on to the next question. Gutters, inlets, and outfall structures must be cleaned every 1 year, 3 months, 6 months, and 1.5 years. Any responses? Okay, so you had answered for the previous question. Sorry. Alright, so from the lecture again, we can see that gutters, inlets, and outfall structures need to be done checked once in every 6 months. The essential idea is that they need to be inspected and ensured of their quality before monsoon arrives. In fact, even in places like Chennai, when we had urban floods, a couple of major disasters in the recent past, one of the major reasons, apart from all the others, was that there was not enough maintenance of stormwater drains. So it can play a very crucial role in mitigating or any kind of um, increased flow of flooding of the urban area, right? So it sort of will help. Any leakage or any defect in this aspect will lead to bad repercussions in the adjoining areas, right? So the answer is 6 months. All right. So moving on to the one numerical that we have in the session, in the assignment, a triangular gutter of concrete. Yeah, yeah, yes, sir.
Sorry to interrupt. I had a question for the previous one.
Yeah.
So we were discussing about how gutters, inlets, and stormwater drains should be cleared every 6 months before
Right.
monsoon and things. Even
Right.
during the lecture, sir had explained about it.
Right.
But my major concern is if that is cleared, will that be a solution to all the flooding issues, especially in Chennai, Mumbai, and all those places where we see the layout, the slope of it is also a very important thing. So what I'm asking is how efficient will this be to manage in such a big city like Chennai or Mumbai?
Okay, so it won't solve the problem, most definitely not, because in case of, I mean, particularly, I'll speak from the perspective of Chennai, for example. It's not just about having gutters or inlets and outfall structures, but it's also about uh, the topography of the city has not really been respected when we are constructing. Essentially, we have encroachments on um, depressions, right, that were previously ponds. Those areas are going to continuously run into trouble. I mean, you have not really, it's not just about filling in land and keeping the structure taller, but looking at the general scheme of things, take the entire city and its topography. If that is a major depression that has been there for centuries, that depression is not really going to disappear by just mere construction, right? So the approach would be to probably go for more recharge structures. And I mean, encroachment has happened. People are not really going to leave those areas. But can we somehow, in the even in the built areas, we do have some scope of increasing infiltration into the ground, or if the stormwater network is sort of streamlined, it can help, right? It can help in directing water out of these areas. So that's one thing. The other reason why we should be really focusing on these gutters and inlets and outfall structures is they can really increase the problem, right? So we are going to be putting stormwater drain structures. Say you are actually putting a very very efficient system in Chennai. You are increasing the underground water reception capacity in terms of a combined sewer or a separate stormwater drain. Something as simple as blockage in the gutters or the blockage in the inlet can disrupt your entire system, right? And all it needs is a bit of inspection. So it's sort of like most the marginal advantage of maintaining these structures is very very high, right? But yes, currently I think most cities are trying to address this issue of urban flooding. I'm not really sure about Mumbai, but in Chennai we have multiple government agencies are actually prioritizing urban flooding and urban drainage. For example, I personally know that CMDA is collaborating with a couple of agencies in order to improve the recharge potential of the city. Even the clearance of Kuam River, for example, the dredging and cleaning of the river has been proven to be quite effective. But the focus, if you ask me, is currently on the parts of Chennai that are problematic. Yes, but uh, were you there in Chennai the last flooding that happened in Chennai, Ashwin?
Yes, I was there,
So,
2015.
if I may ask, which part of Chennai do you live in?
I live in Mandavali.
Okay, so if I come from the northern outskirts, okay, so I live close to Ennore, actually. So it's like beyond North Chennai. The thing is, we didn't have such a major problem. We didn't have, water logging for days on end. No, not at all. Except a few patches again, which directly violated the topography and encroached into water bodies. Our drainage was much more efficient, thanks to probably, I'm probably being politically incorrect, but thanks to the underdevelopment that we have in the northern side, right? However, while problematic areas in Chennai are actually becoming, you know, better in terms of interventions, like say CMDA is intervening, or there's the Sponge Collective agency. I think it's stemming out of Anna University alumni and a few others. So all of these are working on the problematic areas of Chennai. Meanwhile, North Chennai is degrading. So we have instances where once I read in the newspaper how an entire canal, natural drainage channel, has been erased from the government records. Right? It was. I mean, you take the drawing and you delete it and then produce it as the actual existing condition. When further investigation was done, it had been turned into a parking lot or something like that, and it had been built over. So yeah, I guess it's about the entire system being conscious. I'm sorry if I sort of went on a rant.
No, right, okay, thank you.
Yeah, yeah.
I also have a question.
Yes.
What is the difference between excavation and dredging?
So dredging is when there is, say, you have a stormwater drain or some kind of artificial channel, right? And then you sort of, there is siltation that has happened over the channel that was originally open, like clear. So that's dredging. Excavation is usually a priori. Before construction, you excavate the land and then you construct something. So that's like excavated land is green. it's not really been constructed on before, right? Like it's not been uh, excavated before. Okay? Dredging is just the removal of silt.
Okay, okay, thank you.
All right. Do you have anything to add regarding the stormwater drainage situations in either Mumbai? I mean, I'm not very sure about the interventions in Mumbai. If you know of any.
No, I'm not familiar with any interventions in Mumbai as well.
Okay.
But what I see in Chennai is we have a lot of stormwater drainage works happening now, even now.
Right.
Uh, but what I feel is these are basically infrastructure intervention, but the planning of the drainage system itself on a whole, there is still an issue.
Yeah, yeah, because it's investment intensive, right? We need to really find the money to sort of get it done. But Vahi, I think they are trying to work at it at multiple levels. I mean, I know it's always people keep saying, "Oh, we are planning to do this, we are planning to do that," but hopefully this does pan out. Have you heard of the sponge collective?
Yes, yes.
Yeah, yeah.
I had interacted with them.
Yeah, all right. So then you must be knowing that they are trying to actively. It's not just Punch Collective. I mean, if I'm not wrong, CMD is trying to collaborate. It's open to others also giving their input. So yeah, let's hopefully things pan out and hopefully things stop like things stop going wrong in North Chennai. I mean, it feels like since it was not affected, it's out of the picture. So
Yes.
yeah. So moving on to the numerical, right? So a triangular gutter of concrete has a longitudinal slope of 1%, cross slope of 2%, and a curb depth of zero point 0.2 meters. The flow rate and flow depth, if the spread is limited to 2 meters respectively, are, and we have a few options. So essentially, we have data on, first of all, it's a triangular gutter, right? And it's made of concrete. So these are things to be noted. And then we have a longitudinal slope of 1%. So longitudinal slope will be like the direction of flow, in the direction of flow, right? And cross slope of 2%. So cross slope is this, right? Sx across the cross section. And curb depth will be the total curb depth. So y is the flow depth, which we need to figure out, right? Which is this much. However, curb depth is the entire extent of this, right? So, and we need to calculate the flow rate and the flow depth. So, if you remember from the lectures, we can use this modification of the Manning's equation for triangular cross section, right? So, essentially, we need these following. So, Q is equal to Kc divided by N into Sx to the power 5 by 3, Sl to the power 1 by 2, and T to the power 8 by 3. So Kc is the empirical constant that's given 0.376. N is Manning's roughness coefficient. This is where we'll be needing the details on the drain, right? So it's concrete, so our value will be 0.013. And SL is the longitudinal section. T is the width of flow or the spread, right? Which is this part, okay? And Sx is the cross slope, as we saw. Sl is the longitudinal slope. So T will be to the power 8 by 3. Right? So and y, for the calculation of y, which is this flow depth, we just need to multiply T, which is the width of flow, into Sx, which is the cross slope. Right? So we've been given that longitudinal slope is 1%. So these are the given details. We need to find flow rate and flow depth. And we'll be using these equations for calculation, right? So the solution is very straightforward if you know all the values. The flow rate Q is equal to Kc divided by N, which is 0.376. So this value is something that we need to remember, right? Kc is 0.376 divided by n is 0.1013 for concrete. Sx to the power 5 by 3, so Sx is cross slope, which is 0.02, and then SL to the power 1 by 2, which is 0.01 into to the power 1 by 2, so, and t to the power 8 by 3, so t spread is 2 meters, so 2 to the power 8 by 3, and the answer turns out to be 0.0271 meter cube per second. So in the solutions that have been provided for the previous run, the answer is slightly different, but that's because they have taken the Manning's coefficient to be 0.012, right? So usually the Manning's coefficient is provided in the question, but if not, the standard table that has been given in the lecture will come in useful, right? So that's our first answer. The second part is calculation of flow depth, which is t is 2 meters into Sx. Sx is 0.02. Right? So it turns out to be 0.04 meters. The units is missing. I'm sorry. And this turns out to be less than the curve depth that is given, which is 0.2 meters, which means it is an efficient design. Right? So the answer is 0.029 meter cube per second, the closest value, and 0.04 meters. Right. So in the lecture that was given, this was raised in the discussion forum as well. This is an issue that has been highlighted, right? So the value given here is wrong. It has to be 0.376, 0.376, right? So which means this value will also be changing. The answer is actually 0.0303. All right. So please take this into consideration. So that's all from this week's lecture. But again, I would like to share another website. So this is a tool that I found to be extremely useful in sort of our planning exercises during masters. So this is, have you come across this already, Ashwin?
Yes, I have.
You have,
Uh,
right?
I just came across, but I didn't get an opportunity to go through it fully.
Okay, so a shit flow diagram is actually an initiative of the Sustainable Sanitation Alliance. It's a very interesting tool because I mean it makes the whole process fun as well as very informative, right? So I think I have a downloaded version. One second. Yeah. So a shit flow diagram essentially helps you to both calculate as well as represent very effectively the kind of the trajectory that any kind of sewage takes in any city. You can either calculate it for your own city, or the app actually has a few done for existing cities, right? So these are based on pre-existing data. So first what we do is we load whichever city we want to, and then if we look at it, so we have multiple levels of the SFT also. Okay, good evening, Mr. Shripad. Um,
Yes, good evening, madam. Sorry for late because there is no notification in calendar now. That's why we are facing always problem.
that's very unfortunate actually.
Because we have to check the email and now I am trying to remember Monday and Tuesday there will be live session.
Right. There is actually an option to add the Google Meet to your Google Calendar. I mean, I've set reminders myself. because sometimes I forget what day it is. So I mean that's a useful tip. No problem, but the lecture is almost done actually.
Actually finished,
So
na? Then tomorrow the same thing will be covered.
I most probably yes, with a bit of change, but you
Uh-huh.
can also find the lecture on YouTube. But
Okay,
I'll
okay.
be uploading it right like tonight or tomorrow. We just discussed a very few questions and one numerical. That's all. There's not much for this week.
Okay, okay.
Right? So you didn't miss much. Right? There is one numerical that is there, and there is an error in the lecture calculation as well. I've highlighted that. If you want, I can go through the problem again.
Yes, madam. If you have time, no problem.
Yeah. So I'll just finish this introduction.
Hmm.
So this was sort of highlighted in week 8 also. So there is this tool called shit flow diagram, right? So it's a very good tool in order to sort of visualize the flow of sewage in a city. Right? We are looking at a very typical, I mean, something that's pre-existing in the app itself. So once you enter which what kinds of sanitation systems are being used in the city. For example, in Trichy, that's what we've opened. So there is no on-site container. What are the things that are actually happening? Not the percentage, but okay. So from toilet to open ground, and then there is open defecation, and people don't know where. So these are responses based on the survey responses. We fill in these details, right? And then we can determine how much percentage is going into each system, like septic tanks, fully lined tanks, lined tanks with impermeable walls and open bottom. So you given how much percentage is the case, right? So then we create the SFT matrix, right? So this data population 4536337, if I'm not wrong, is from the socio-economic class census, right? So once you give all of these details, you can generate your SFD shit flow diagram. So basically, it summarizes as to how much of the sewage is being handled properly. So in this case, it's 60%, and 40% is being mishandled. And then it also gives you a breakdown as to uh, which sewage is being mishandled. Okay, so on-site sanitation is being heavily mishandled. Off-site sanitation is decently being, addressed, right? And it also sort of gives you as to which scale things are going wrong at. So it's in case of this city, it's going wrong at the local area or the neighborhood level, right? So it's a very efficient means of representing what's happening. You can download the data as well in whatever format you want. It's something that I really like using during our planning exercise as well. So just a small recommendation, right? So before we repeat the problem,
Madam, what was that? That was
it's
on Excel sheet or app or any software.
it's a software, but it's also available online. So it's you can download it from this website sft.susana.org. It's part of the, if you look at the week 8
Uh,
slides, I've given the link
uh,
there, right? So you can download it, or you can, I think there is an option to, yeah, graphic generator is something that you can use online if I'm not wrong.
it is related to survey only.
You will need the relevant data.
Basic data.
Yes,
Hmm.
yes. So in case of India, you can actually use SECC data for the respective city, or if you conduct a primary survey, take a sample and then you figure out the numbers, then you can use
Hmm.
this to visualize, right? So it's more of a visualization tool. Okay. So before we move on to repeating the numerical, any general doubts, Mr. Ashwin, from what has been taught today?
No, nothing regarding today, but something regarding last week. Unfortunately, I was not able to attend last week's session, but I managed to go through the recording.
Yeah.
Uh, I believe that we had a clarification regarding the formula Q is equal to 10 times CIA.
Yeah, yeah. So
I had the same.
I've actually intimated the team, as to
Okay.
post a solution. So I didn't want to disrupt this week's lecture, so I didn't really prepare for it.
Okay.
But I think we'll be posting it on the discussion forum,
Okay. Okay.
right?
Thank you.
Because holidays are up, it's a little difficult to catch hold of people. Nobody's here.
Right. Right.
So yeah, yeah. As to why there are two formulae, I'll post it in the discussion forum.
Okay.
Right.
Thank you.
Yeah. Or I will also, if I'm posting a say file or something, I'll probably add a link in the YouTube video description as well. I'll let you know in the next class as to where I've
Sure.
added it. Right.
Sure. Thank you.
Yeah. But if you don't have anything else, I think we are done for the day, Mr. Ashwin. If you want to leave, like, you can leave. I'm just going to repeat the problem.
Okay. Thank you.
Yeah, this is for you, Mr. Shripad, right? So we are
Yes,
actually
ma'am.
looking at the previous week's questions. Uh, we looked at three theoretical problems which are almost straightforward, but we also had one numerical, right? So I'm going to be solving that numerical right now. So a triangular gutter of concrete has a longitudinal slope of 1%, cross slope of 2%, and a curb depth of 0.2 meters. The flow rate and flow depth, if the spread is limited to 2 meters respectively, are, and we have a few options, right? So let's look at what all information has been given. So we need to, first of all, we need to calculate flow rate and flow depth, right? And it's given that it's a triangular gutter of concrete. So we will need this information because this is where we'll be getting Manning's roughness coefficient from, right? And then we have information that the longitudinal slope is 1%. So there are two kinds of slopes in a triangular gutter. So one is this slope when you cut a cross section, and then this slope is Sx, right? However, the other one is this slope. So because if you take the other cross section, right?
This is
And
longitudinal, na?
sorry.
This slope is longitudinal
Uh,
along the gutter.
yeah, yeah, along the gutter is longitudinal. Yes, exactly. So this one is cross sectional and that is longitudinal. So very bad depiction, but yeah, right. So this is along the length of the drain, the gutter, right? So longitudinal slope of 1%, cross slope of 2%, and curb depth. Curb depth is, so we have two depths here. One is the depth of flow, as in it has been determined as to how much fluid is flowing, right?
Mm-hmm.
And one is the
Top of the
curb depth. Yes, the entire, this is the curb top, so that is the curb depth, right? And spread is the width of flow, right? So this is spread 2 meters. So that is the information that we have, right? So if you remember from the lectures, we have this slide on gutters and inlets,
mm-hmm.
and we have a modification of the Manning's equation for a triangular cross section, right? So this is the equation. If you notice, we have Kc divided by n into Sx 5 by 3, Sl 1 by 2, and T 8 by 3. So Kc is the empirical constant, n is the Manning's roughness coefficient. If you remember, it's a concrete gutter, right?
Concrete
So
gutter,
for a
zero.
concrete gutter, the value is 0.013. And then Sx is the cross slope which has been given. Sl is the longitudinal slope given, and T is the uh, width of flow, which is spread. So these are the given data. We need to find flow rate and flow depth. So the calculation is actually quite straightforward. We need to substitute all the values into the equation.
No problem, got it.
Yeah. So that will be Kc divided by n, 0.376 divided by 0.013. Sx is 0.02, Sl is 0.01, and T is 2 power 8 by 3. So if you do the calculations, the value comes out to be 0.0271 meter cube per second. But if you look at the previous week's solution that they have given, the previous, sorry, not previous week, the previous run of the course. Last time the course was run, in the solution the value is slightly changing. This value is slightly changing, but that's because they have taken the Manning's coefficient to be 0.012. But from the lectures, it's given as 0.013, 0.013. So we'll be taking this value only. Usually Manning's coefficient will be given with the question, right? Or
Hmm.
even otherwise you can refer to the any of the slides from the lectures and then cite that value, it should be fine. Just make sure you state the assumption when you're writing in the exam, right? So
Okay.
we also have to calculate the flow depth. So flow depth is again straightforward, right? So it's T into Sx. So T is 2 and Sx is 0.0. So the value is 0.04 meters. Sorry about that. Yeah. So these are the answers. But if you notice, the flow depth 0.04 meters is less than the curb depth, right?
Hmm.
zero point 0.2 meters. So which means the design is sufficient. That's what they're trying to say.
Okay.
So that's the answer. But this was brought up in the discussion forum. So this is the problem that was worked out in the lecture, right? And if you notice here, the empirical constant has been given as 0.376, but they have taken the wrong value in the equation itself. So this is wrong actually. So this has changed the final value also. The value should be around 0.0303 meter cube per second. So please make note of this also. Right. So I'm
But
letting you
this is
know
from
because
the, madam, this is from the lecture 10
yes,
or 11? 10, right?
yes. This is from lecture 10.
Okay.
Lecture number 46, 10th week ka lecture, module 10.
Okay. Okay.
Yeah.
Okay.
Right. So this problem sir had worked out, but unfortunately this value was wrong. So because of this, the answer is varying slightly. Right.
Okay.
So
Okay.
that is all for this week. It was quite basic because most of the answers are repeating in the current assignment.
And during the final examination, all the constant will be given, or that we have to assume?
So most of the constants will be given, but some things like, for example, Manning's roughness coefficient. There is also the
Hmm.
CH value. For
Hmm.
example, cast iron pipe is always 130, right? So
Hmm.
they might give you the material, and you will have to
Hmm.
remember the values from the lectures. Only the coefficients, nothing else.
Okay. And final examination will also be same pattern, MCQ?
I'm not actually sure. I mean, I'll let you know. I'll take
Okay.
note of. I'll
Okay.
ask
Okay.
them to release the pattern of examination.
Okay. Thank
Any
you,
other
madam.
queries?
No, no. First, today I will go through this assignment,
Yeah.
assignment and lecture, because 10th and 11th I have not attempted.
Okay,
That I
okay.
will.
Okay. Yeah. So, I mean, even today's we have three theoretical problems that are very direct. So, you can just
Hmm.
go through the recording, right?
Okay.
All right. Fine
Okay.
then. Um, see you next week.
Okay. Thank you.
Yeah.
Good night.
Thank you.